API Conference, Elevating API Literacy.
So we are just going to do a quick intro to the blockchain, having established that baseline for APIs. Guys, to be very honest, the blockchain, I've been in this space for about 8 years now, right? And to be very honest, the best use case is still with money, finances. Of course, there are other arguments about the various use cases and possible implementations of using blockchain, but being here that long, going close to it now, I can tell you without any shadow of doubt, the best case for the blockchain is finances, is money. So the thing that makes it unique about money, it's the sense of ownership it brings to an individual, right? So in typical Web2 environments, you have services like Facebook, Twitter, and all of these other big guys that you go sign up with. Then they own your data. At any point in time, they can decide to kick you out, right? People can mass report your Twitter account, and Twitter decides to kick you out. So there is no sense of ownership in those systems. So basically, a blockchain is where you have a sense of ownership. You want to put out a tweet, you put it somewhere, and then you pay somebody to store it for you, right? When they store it for you, that means that nobody else is ever going to delete it. It sits as a record there. So I was trying to find, typical everyday analogies that I can use to explain it, to just make it simple enough, right? So at first, what was here was, a blockchain is simply a list of noisemakers in a classroom, where the prefects have to agree on the names to add. I was like, no, maybe that didn't, communicate my intent as much as saying blockchain is a running list of school prefects, right? Where the teachers have to agree on the names that are added to the list every year. And then this stands as a record. A blockchain is what we describe as a read-own-write operation, right? Unlike typical Web2 where you just read and write without owning, or blockchains, you are able to own whatever is on here. So that segues into understanding the differences between Web2 and Web3. And I think another steep learning curve when we talk about Web2 and Web3, people tend to think of it as different forms of internet. But that is not the case. Interactions across Web2 and Web3 environments happen on HTTP, basically, right? It's still the internet. There is practically no difference. So it has just become an ecosystem standard to use the terms Web2, Web3. But for the life of me, I really do not see any difference, right? Except for this unique thing about ownership of data. For Web2, user doesn't own personal data like I said, but for Web3, user owns personal data. Web2 is typically free for use, Web3 is not free for use because you have to pay for any data that you're putting on there. So Web2 is distributed, Web3 is decentralized. The critical difference between these two things is when you think of
So distributed, decentralized, right? With distributed technology, you can think of a service like AWS, right? You have possibly, maybe, I don't know, Facebook hosting their data on AWS, right? And then they have this data across different locations, but it's the same data. So basically, if you send out a hello world post and it's stored somewhere, if their servers in the US are down, and as long as their servers in the EU are still working, you still have access, right? If their servers in the EU are down, if they have servers in Africa, you still have access. But with decentralized, so it's basically still servers, right? But not copies of each other. With distributed, it's typically copies. But with decentralized, you have a system where you have like 1,000 computers. That's 1,000 computers are running one piece of software at the same time, right? So what that then does mean that if you send an information to this decentralized network, everybody gets to see it on their machines at the same time. It is not stored as individual copies on top of each of these machines. No, it's the same data on these different machines, right? Is that making sense? That's okay. No, if it's not making sense, it's fine, right? So let me take it again. With distributed technology, you know, practically when we say a server, we are basically saying a computer, yeah? So we are basically saying a computer. So that means that if I have a notepad open on this machine and I write, my wife is the love of my life on that notepad, right? Yes. So, and then that machine is on there, right? And we establish a connection, right, over HTTP. And I now take a copy of that note and put it on there. So then we now open an IP port. And I say, this is an IP address. We have this data stored. You can access it. Now, I have that same data, but 2 copies. So what that means is that, but distributed over one IP. What that means is that if I shut down this machine, you can still access the data from that machine, right? So that is distributed. Does that make sense? That makes sense. So, but with decentralized, right? Now, take that same Notepad program, right? But this time, we are running it in a piece of software like a VM, right? Now, that VM, when I am running it on here, if I take that same VM, right, and I'm running it on there, what that then means is that the 2 VMs running in these machines, they are not separate copies. Neither are they clones, but they are actually the same virtual machines. So if on a notepad, I still write the same thing, my wife is the love of my life, right? Immediately, I send that information to this VM, right? That VM still sees that information. If the ID here is 1, it still reads there as the ID being 1. So it's not a copy, it's the same piece of data. But with blockchain technology, for every data that you send, every note that you write into that VM, as you're uploading it, you are not able to update it anymore. Neither are you able to delete it. So that is why you pay for it to be stored on the blockchain. So if you have 100 computers, right, and then 99 shuts down, as long as one is still working, you can still access your information. So that's basically just it. And then someone found a way to create digital money that it's not, cannot be destroyed and cannot be copied, and then put it on one machine and made it hard for people to use mathematical equations to solve for it. That's what's led to the creation of cryptocurrencies and all of those things, right? So having established the foundational knowledge for APIs, for blockchains, I think this is where we can look at examples, right? So with APIs, if you are using the REST protocol, so you have your typical CRUD operations, where you're able to create, to read, to update, to delete. I think one of the things that made learning about technology very easy for me was when somebody said every piece of software, every single piece of software that you can ever think about is actually a to-do list. Every single piece of software is actually a to-do list. You want to be able to write to that to-do list. You want to be able to read what you have written on that to-do list. You want to be able to update what you are reading, and then you want to be able to delete it, right? Every other operation that you now do with your middleware, with your whatever it is, still falls on top of those particular operations. So with Web3, the similarities between these operations on Web 2 and these operations on Web 3. What we call create using REST APIs is called write. Read is the same thing. Read operations are the same thing. But with upgrade, it's a little bit tricky, and I'm not going to go into that in here, but we do have what we call upgradable smart contracts. But with delete, I was thinking, should we describe being able to destroy born tokens as delete, but maybe not, right? But what I want us to focus on here during this session is the fact that when you're able to create in Web 2 using post, you're able to write in Web 3 using a method that we call it call, right? We'll go into that later. Those are like standard, agreed upon standardized requests, just as we have CRUD operations. What we can do using read, we also have, read examples. There are other examples that exist on here. So we'll just focus on that. The key difference being that over there, you don't own whatever you are creating, neither do you own what you are reading. You can be kicked out of any distributed system anytime. Over here, with read and write, you own what you are writing and you own what you are reading. So just to underscore everything that we've been speaking about, Web 2 uses HTTPS to send data, read data between a UI and server using, for example, JSON, right? Show of hands, how many people here know what JSON responses look like? Thank you very much, right? So Web 3 also uses HTTP. Like I said, these are not different internets to read and write data between UI and smart contracts. But as against just using reading play JSON, we use remote procedure calls to connect to those nodes that I described earlier, right? And this is not very, very clear. Remember, I shared an image earlier where I was like, you have your user interface, you have your APIs, you have your server. But with Web3 technology, you have your user interface. Instead of having your APIs in this instance, we have the RPCs, right? And then we have the blockchain. So these are individual, is that like time up? Okay, these are like individual servers in the decentralized network. So we use RPC calls to connect to them, right? So it's practically not so much of a difference, right? So basically, I am going to share the slides afterwards because I want to see if we can quickly rush to what I want to get to the meat of the whole thing, right? So if you can take your mind back to the image I just shared, the user interface, RPC, and then the servers, the slides, sorry guys. No, I think you've moved away from it. Okay. So the slight difference here is that before RPC calls, I introduced SDKs and APIs, right? So now this makes it easy for any Web2 developer to be able to connect, right? Without understanding or without even having to learn basic blockchain technology. So as long as you know how to read APIs, of course, how to read SDKs, you are able to build full functional applications. So Code Lab, we are meant to just build a smart contract wallet for sending tokens using the Fuse Web SDK, right? So practically, you know JavaScript, you understand SDKs. You can either use Fetch or Axios. This was meant for the API, but since we are not making API calls, we'll just focus on the SDK methods. So, but first of all, you would have to get our API key to be able to build using our SDKs. And then, tricky enough, you can use just these 4 methods here to build out a full-fledged application where you have users that are able to create accounts, right? They will sign up, create an account, and then you give them an address or what we call in typical Web 2, a bank account, right? And then from that bank account, they will be able to make deposits, and then they'll be able to make transfers. So with making withdrawals, you might have to use a third-party off-ramping service because you need to convert crypto to actual cash. But again, with just these 4 methods here, you can build out a full application, right? So it's the SDK. It's very, very easy to use, right? Once you have your API keys, and once you are able to get we integrate with partners where you can provide, instead of using, for those that are not very familiar with Web3 technology, instead of using what we call wallets in Web3, you can just use an email account and then create those bank accounts, but in blockchain terminologies, those smart contract address. Are we done? Okay. Those smart contract addresses, right? And then have users be able to like carry out transactions. So with all of these, with this particular method, where you are able to initialize an account, you are able to like create an account for any user, right? And then that user will be able to just see their bank account or their wallet address just by calling the get sender method. It returns it to them. So this is basically a read operation, right? The first operation was a write operation. This is basically a read operation. Same thing, getting a balance, right, for a particular token. You just pass in the token address, pass in the account balance or wallet address. Sorry, I'm trying to like switch between Web2 and Web3 technologies. Account balance or wallet address of the user, and then be able to show them their bank balance, right? And also just one method to be able to like make transfers out of their accounts, right? So this was practically the session where I would switch here and show you just a full functional application, right? So, like I said earlier, any app that you can think about, you can think of it as a notepad, right? You want to be able to like create, read, update, delete, right? So with this is basically a very, like the most basic of applications in enabling people be able to transfer money from their accounts, right? So what you are looking at here, it's a wallet address, like the user's bank account in this case, right? And then a very simple form where they want to like transfer to somebody else. They can enter their address, enter the amounts they want to transfer and send, yeah? But I just want to quickly show us, before carrying out a transaction, what that code looks like. So this is built out, this example is built out with Next.js. Can everybody in the room see this? Okay. But even if it's not clear enough. So I'm going to share the link to these resources so that you can go take a look at it. So what we have done here is use a helper function to like initialize everything, initialize a function that we are going to use later on. Round up. Okay. So that we are going to use later on, right? So guys, like I promised, right? All of these I'm going to make available. I think I will just, right after this session, I'm just going to like send it out on Twitter. But one of my objectives for this session, if there is nothing else to take away from all of this, right, is that I want to invite you guys to come participate in a, do I have internet? I want to invite you guys to come participate in a hackathon that we have running on Dora Hacks, right? And I just wanted to like use this session to illustrate how easy it is to build out applications using the Fuse SDK, right? So let me see. The hackathon actually opened up on Monday, and there are still like 2 weeks to submissions. Sorry, it's not as fast as Fiber1, but I think it's still loading up. So, okay. I just want this to quickly load so that I can share it with you guys. Okay, yeah, there it says. So if you come on dorahacks.io, just go to the hackathons tab, look at the ongoing hackathons, and then search for the Fuse hackathon, right? What you want to do to indicate interest is, first of all, register as a hacker, and then you are able to like participate in other activities that we'll be having during the course of the hackathon, right? And who knows? I mean, I believe in the serendipity of life. I didn't believe that I was going to be here like a couple of years ago and all of that. So this is the point of the session where it is aspire to acquire, right? And yes, so I'm going to say that. So for what is what, if you find any ideas where you believe that it has the potential to become something that solves a problem, right? I would encourage you to participate in the hackathon because we are providing ecosystem support away from the hackathon. So, and the hackathon is a way that we want to filter for projects that we can provide grants to, right? And the grant starts from as little as 10K to as much as your requirements would be. So I want to see what kind of ideas that you could possibly build, win a prize, and then explore the grants. Of course, it's free money. So if the grants doesn't inspire you, for what is what, participate in the hackathon. I mean, $1,000 right now, it's how much? Thank you very much. It's been a pleasure doing this with you guys.
API Conference, Elevating API Literacy.